Welcome back to our coverage from AWS reInvent 2017. My name's Ian, I'm a technical evangelist here at Amazon Web Services, and you're joining us live from AWS reInvent, which is our global user education conference with just about, 43,000 of our best friends, many of whom you can see behind us here in the expo. We're joined now for this next segment by another one of our service teams here at AWS, the service team that had an announcement in this morning's keynote with our CEO, Andy Jassy. And to my right, to your left, is Tara Walker, one of our AWS evangelists and somebody that has a lot of knowledge of AWS IoT and associated services. And Tara is going to be leading this next segment for us, and she's going to introduce our guests. Over to you, Tara.
Yeah, did you notice I'm tall? Okay. Well, wonderfully enough, I'm here with, again, another great launch team. And so I'm not going to steal their thunder. We've done this before. I'm going to let them introduce themselves. They are from the AWS IoT product group. Guys, want to introduce yourselves?
Yeah. Hi, hello there. My name is Satyen Yadav. I'm a general manager in AWS IoT. And along with me, we have one of our lead engineers for Amazon FreeRTOS, Dan.
Thanks, Satyen. My name is Dan Griffin. I'm a senior software engineer on Satyen's team. I worked on the Amazon FreeRTOS project, and my background is in software security. That's my passion, to work on software security and cryptography specifically. And I was able to make some contributions in that area to Amazon FreeRTOS. So that's my interest.
Yeah. Okay, so I am obviously geeking out over this. So we've been talking about it quite a while. I have my microcontroller all ready to go, but why don't you, for guys out there that haven't played with it yet, that are not really as geeked as me yet about it, because they don't know about it, tell them about the new Amazon FreeRTOS product and some of the benefits of it.
Yeah, so first is there are smaller devices which are based on microcontrollers. They're all around you. They are in your dishwasher, they are in your washing machine, fitness tracker, your thermostat. So they're all around you. So there are billions of devices already there. And FreeRTOS is a operating system that is one of the #1 operating system in this space. So there's a difference between microcontroller and the CPU-based devices you may understand. First is there's a much lower cost, much lower power, obviously much lower constraint in terms of the resources available to them. So there is a specifically designed small footprint operating system like FreeRTOS. And FreeRTOS was designed to go into the embedded space, but not necessarily have the features to get into connect to the cloud, security, managing the over-the-air updates, things like that. So what we have done with this already very good operating system is added certain libraries to make it extremely easy for the developers to use it in a IoT application, and so that's the primary thing. This is open source project, was open source before, free to use. One of the things we have done is we have made it even much easier by introducing this under MIT license, which is basically there's no restriction to our customers to use it, and also we have upgraded the underlying operating system or kernel, which is with version 10. And so we can talk about those features with that. But overall, we are expecting this will make our developers' life easier, the device manufacturers' life easy to onboard billions of devices. If you're going to expect 50 to 100 billion devices come on board, it has to be extremely simple to do it.
Right. What sort of connectivity do the target devices typically have? Because these are really low-cost, lightweight, small devices. I'm guessing you're probably not talking about 4G or LTE connectivity. So how do these devices communicate back with the cloud? What's the model?
So there are a range of technologies could be used. So first is the Wi-Fi, which is the predominant. So most of the indoor application can be covered through Wi-Fi. There are applications using cellular technologies. There's cellular technology which are relevant to the space. Or narrowband IoT is another term for a new technology coming, or LTE-M. Which is for the M2M application, and I was demonstrating the LTE small button earlier this morning. So there are a range of technologies within local environment. You may have Bluetooth Low Energy or Zigbee, or there are a number of other industrial protocols that one could use. So there's a range of technology. In case these devices are using local protocols, then they will use one of the hub type of devices. So we have AWS Greengrass that could work as an edge control, and then other devices could so Treadstone, Turkstone was a code name for this project, but Amazon FreeRTOS based devices could connect to the Greengrass and then get onto the internet.
Yep. Okay.
So I'm really curious about, so you talked about the fact that this was and is an open source project,
Right.
freertos.org.
Yes.
I've followed the community, so I'm sure people that are out there that are in this community, they're really interested in, hey, I'm familiar with what this great operating system did before, and I could build my libraries on top of it, expand that. What is the difference between now what was there and what we're providing with it now being Amazon FreeRTOS?
Okay, so at the highest level, first we made it extremely easy to distribute. So all our customers and partners are interested in building their devices based on it. With MIT licenses is one of the most unrestricted open source licenses you can find. In terms of the core, I'll let Dan talk about the core features, but we have improved the version 9 FreeRTOS kernel to version 10. And then we have connectivity library, this protocol called MQTT, TLS library, which is for the securing the connection. And then we also made easy to connect to the locally to AWS Greengrass. So there's a Greengrass discovery and Greengrass connectivity library. So those are the high level, but maybe we should let Dan speak and talk about the core features. Then he can cover the core features.
Tell us about the goodness now, Dan.
In the kernel, talking about some of the new capabilities in the FreeRTOS 10 kernel, Richard Berry, the author of FreeRTOS, who I've had the privilege of working with for the past several months.
Pretty fantastic, yeah.
He's made a big investment in the inter-process communication features of the FreeRTOS kernel. And when I say big investment, I think it's important to note that when you're talking about embedded software and a real-time operating system, and then you consider the ubiquity of microcontrollers, everything from toy trains to commercial airliners, it's very important that you get it right. Software quality is everything. So when you talk about adding a feature like stream buffers for inter-process communication in the V10 kernel, it's not just reaching code complete, so to speak. It's the testing and the quality work,
robustness,
and the porting across all of the chips and
hardware
and the platforms, the hardware that Richard has supported all these years. That's where so much of the effort goes into, and it's really easy to overlook how much work that is. And then again, it's a great privilege to have been able to start with that point and add the connectivity libraries that Satyan mentioned, and really be held to a very high standard. The quality of the libraries that we have to achieve in order to kind of maintain Richard's standard.
Right.
Shall we say?
It was literally the #1 downloaded real-time operating system out there. So I'm sure, and just if you ever went on the site, like I said, I kind of checked out the community, obviously. If you ever went on the site even prior to this, if you see the vast amount of hardware controllers and everything else he supported,
it's
from a
everywhere.
it's everywhere.
It's everywhere.
It's amazing.
Yeah.
So what about, so you said you were into security, so we got to ask, right? He mentioned that obviously we have now TLS is a part of the core, but tell us more about what is now being done, because this is a big hot thing, making sure we're securing our microcontrollers as we broaden our new IoT world. Talk about some of the security features within it.
I think that what's very interesting to work in IoT right now is the evolution of, we're not only talking about these vast numbers of devices, but now we're talking about these vast numbers of devices that are becoming connected to the internet.
Right.
And that means you have potentially a very different threat model for privacy, for data theft, that wasn't necessarily at the forefront of product designers' minds, maybe 10, 15 years ago. And again, it's our obligation as library designers to make sure that we account for that, to make sure that the product we deliver, the SDK, let's say, that we're delivering, is secure by default, secure by design, secure in deployment, and make that easy for the customer to get right.
Yeah. And so you kind of Well, we didn't plan this. I promise you we didn't, but you kind of just immediately went into the question I was going to ask, right? So a lot of developers out there are like, okay, that's cool, I want to get started. Can you talk about, you said that we're going to have a great SDK or interfaces. So I'm a software library developer, let's say, and I'm thinking of this great thing I want to do to interface and put it out there as a software library for other people to use in whatever industry you're in. Talk about the interfaces and how it is either easier to do this, or we have the ability to do it with some of the SDKs or APIs or the things that you're adding to make software library developers or engineers able to dig in immediately. How do we let's get dirty, our hands dirty, how we do that, right?
The feedback that Richard Berry, FreeRTOS author, that he shared with the team at the start of the project is that customers were saying loud and clear, it's too hard to port applications. It's too hard to take an existing app, switch out a new hardware platform for whatever reason, to take your connectivity library that uses protocol X and to just change your application to use protocol Y. I think a major contribution that we've made, therefore, in what we've added to FreeRTOS isn't just the reference libraries themselves, but it's also the interfaces that we've designed and that our launch partners are working with, are adhering to.
Yeah.
So now that we know that once a customer has written an app to those interfaces, they have that kind of plug and play ability down the road to kind of grow with the product.
Let's talk about protocols. So I'm getting a question on Twitch stream, and it's actually an interesting one. We talk a lot about the MQTT protocol, right?
Yeah.
Great protocol, we all know it and love it and use it, but as someone on Twitch was wondering, are there plans to support the AMQP protocol more easily with this?
Yeah, so in terms of adding, because it's an open source project, all the interfaces are openly available and the rest of the code could be easily seen. So obviously customers and partners can write themselves and add the product. In terms of this specific protocol, we would have to take the input and then decide where it fits. At this point, we don't support it. But that's just because we don't have a specific protocol support doesn't mean the others can't contribute. So one of the good things about open source projects are others can contribute and share with the rest of the community. And so we welcome those contributions.
You mentioned launch partners there. Can you just describe a little bit more about what the role of these partners is and who's in this list of launch partners that you're collaborating with on this product? Yeah,
so we have two types of partners. So first is this is operating system runs right top of hardware. So microcontroller vendors. So we are going out with TI, Microchip, ST Micro, and NXP, and so their boards are readily available, fully tested, and available for downloading. So the first set of partners are all these microcontroller vendors. Will expand that quickly. When Richard Berry had his FreeRTOS, so core kernel actually can run much beyond than 4. I'm talking about what Amazon FreeRTOS with the extended library that we have.
Yep.
So we'll be covering the microcontroller vendor space very quickly. The second class of partners are around people who build the tools. So we have few partners going with us who have Percepia, who makes the debugging tools or tracing tools. And so IAR, so there are 3-4 other software vendors that are going with us to complement the rest of the development ecosystem.
Understand.
And so we'll continue to grow both of this keeps falling. We will continue to grow that ecosystem to bring as many tools and as many different aspects of the project that customers need.
So let's talk about, so we talked about tools, so I'm going to get into, I want to start, I'm ready to go.
Yeah.
And so I'm kind of cheating because I have at least looked at it a little bit, probably more so than so let's talk about simulators, and this I actually am reminded about simulators. Somebody on the Twitch channel was talking about it. So let's talk about if I want to get started and I want to use the simulator to test and get started. Again, I don't want to answer this because I will be cheating a little bit because I know. I want you guys to talk about what's available for guys to get started and some of the simulators and other things we have out there.
That's a perfect point. I didn't touch on it. I'll let Dan actually finish it.
Okay.
Go ahead.
So I think that there's an important point to be made about using the simulator, which is, I would say there's 2 points actually. One great thing about Amazon FreeRTOS is that we've made it very easy, and the simulator is a great example of this, for non-embedded developers to get started in embedded development.
Right.
Because you don't have to ramp up on a new tool chain necessarily. You don't have to ramp up on I have to learn hardware kind of thing, right? The simulator, it runs in Visual Studio. You can actually use the community version of Visual Studio, which is free for open source projects. And it runs on Windows, and so basically you can run it on your laptop, and that's all you need. I think the second point I want to make, though, as somebody, speaking of myself, coming from a hardware security background in the client-server world, is that you don't really learn embedded development. You don't really learn IoT until you get a development board and you actually try it out. So try the simulator, but don't stop there.
Right.
Keep going.
Yeah, and then you're like, wait, why is this not working? And
you only learn when you have that first, why is this not working?
Right? and you get the gray hairs and the pain points. But once you get past it, you're like, I got this. It becomes fun afterwards. So someone also asked, we talked about the simulators. I'm a VS person, so I love the tool. But someone asked about what about simulators for Mac? So I gotta be understanding that obviously they asked about it. They asked, I say,
That was the very first question. I'm a Mac user.
Okay.
And then when the team said, you could try this out, and I says, how can I try it out? They say you have to go to Windows. So I can't really tell you when, but we will definitely want to have a Mac
Presumably you can run the simulator on a T2 Micro using Windows on the AWS cloud, though, right?
So there's a couple things you can do with Mac. I know this because a good friend of mine, a colleague on my team, is a hardcore Mac user, would never pick up a Windows
we
laptop.
We have some of them out there. I'm looking at some of my team. Go ahead.
So he's running Visual Studio Simulator for testing that platform, in a VM on his Mac. But some of our vendors actually do offer their tool chain, the GCC-based tool chains. Those run on Mac. So if that's actually another reason, if you're a Mac user, to get your hands dirty and get an embedded development board and just go straight to that.
Essentially cross-compiling in GCC on the Mac and then flash that onto the device and away you go.
You got it.
All right, so we're going to wrap it up, but tell us, how do people get started? Giving them the links, giving them ready to dig in and go for it. Like me, I'm going to destroy a couple of microcontrollers, I'm sure. So tell these guys how to get started too.
It's very easy. You go to awsamazon.com/FreeRTOS. That's one place you'll find Amazon FreeRTOS libraries and our partners who have pre-qualified their boards with us. Also, if you happen to be existing FreeRTOS user, you can go to freertos.org and get the FreeRTOS version 10 kernel. So you could go either places and get the information.
Or GitHub.
Or GitHub.
And GitHub, yes.
Download the source.
GitHub.
Thank you.
Yep. All right, guys, thank you so much. We've enjoyed these guys, and hope you've been enjoying the stream just as much as we've been enjoying being here talking to you.
We'll be right back.
Yep, see you later.
See you soon.
Thank you. Bye-bye.